honored professors, and estimated members of the jury. My name is Baran Şahin Çelik. I am student of Electrical Electronics Engineering, İzmir Katip Çelebi University. Today, I am highly pleased to present my graduation project titled Design of a Waveguide-Based 2.45 GHz microwave system for food driving, which is supported under the TÜBİTAK 2209B program. In the food industry, traditional methods used for drying high moisture products such as corn lead to significant energy losses and prolonged processing times. Microwave technology, with its volumetric heating capability, has the potential to drastically minimize these processing durations. However, this introduces a major engineering challenge that must be overcome: non-uniform heating and asymmetric field distribution caused by standing wave patterns, which often lead to hot and cold spots. Okay. Voltage amplification, high voltage transformer. The 220 voltage alternating current supplied from the grid is initially applied to the primary windings of a high voltage transformer. The secondary windings of the transformer are designed with a significantly higher turn ratio relative to the primary through the principle of electromagnetic induction. The 220 voltage AC grid voltage is stepped up to approximately 2000 voltage, 2100 voltage AC at the secondary output. Okay. Additionally, these transformers typically feature a separate low voltage secondary winding dedicated to heating the magnetron filament, which provides around 3 voltage AC for cathode excitation. 2. Rectification and voltage doubling, high voltage diode and capacitor circuit. Okay. The 2000 voltage AC voltage stepped up the transformer cannot be used directly because it is still in an alternating current waveform and falls short of the 13 volt threshold required by the magnetron. This is magnetron. At this stage, a high voltage capacitor and a cases grounded high voltage diode are integrated into the system. Together, these two components form a voltage doubler circuit. During the positive half cycle of the AC wave, the diode becomes forward biased and the current from the transformer charges the high voltage capacitor. A peak voltage of approximately 2000 voltage is stored across the capacitor. During the negative half cycle of the AC wave, the diode becomes reserve biased. At this moment, the 2000 voltage produced by the negative half cycle of the transformer stays in line with the 2000 voltage already stored across the capacitor. Due to the series connection principle, Consequently, this cycle provides a stable rectification in a microwave power system, producing a high voltage pulse of approximately 4000 voltage DC at the output. 3. Magnetron triggering and microwave generation. The resulting 4000 voltage DC potential is applied across the anode and cathode terminals of the magnetron. During this process, the following physical phases take place. Thermionic emission, the cathode heated by the low voltage winding, begins to electrons from its surface. Electron acceleration, this massive potential difference of 4000 voltage accelerates and hurls the electrons from the cathode toward the anode at extreme velocities. Magnetic field deflection, powerful permanent magnets positioned around the magnetron apply a perpendicular magnetic field to these accelerating electrons. Due to the Lorentz force, the electrons are deflected from a linear path and begin to rotate in circular and spiral orbits around the resonant anode cavities. Resonance and microwave radiation, specifically at the standard industrial and domestic frequency of 2.45 GHz, this generated microwave energy is captured by an antenna and fed into the waveguide to be directed into the drying cavity. In summary, converting the 220 voltage AC grid voltage into 4000 voltage DC via the high voltage transformer and doubler circuit is the core triggering mechanism that imparts the necessary kinetic energy and velocity. Okay. Let's working this system. Yes. Firstly, it is starts to second time. Yes. And start. It sounds zzz. Okay. Yes. Repeat. 10 seconds. Start rest. There is high electrical field. It stops. Yes. Difference between yes. Repeat. Let's start. Yes. Thank you for watching.